Okay, we have another gross chain rule problem that's going to involve a lot of square roots. Let's jump right into it. The derivative f prime of x is going to equal 5 divided by x minus the square root of x squared minus 1. All I'm using here is this derivative rule here. I'm just saying the derivative of ln of x is 1 over x. So derivative of ln of blah is 1 over blah. So here we have 5 ln of blah. So it starts off with 5 over that blah. Then we have to say chain rule. Is there something inside that ln? Sure, there sure is. It's x minus square root of x squared minus 1. So I got to take that function's derivative. The derivative of x is 1. The derivative of square root of x squared minus 1, I'm going to actually go ahead and rewrite this square root of x squared minus 1 as x squared minus 1 to the 1/2. So it's a little bit easier for me to use that power rule. So the 1/2 will come down in front. Don't forget it's a minus. So minus 1/2 x squared minus 1 to the negative 1/2. And there's more chain rule to consider. Actually, I was about to close the parentheses there, but there's still something else. What's inside the square root? Is there something inside this parentheses that needs to be taken care of? Yes, there is. Chain rule says every time you take the derivative of a function, you got to take the derivative or multiply by the derivative of the inside function. So what's inside this parentheses is an x squared minus 1. The derivative of x squared minus 1 is 2x. Okay, there's a lot of cleanup here because this is not just yet a final answer. I'm going to go ahead and say 5 over x minus the square root of x squared minus 1 times 1 minus, let's do a couple things. I see this 1/2 and that 2 will cancel. This x squared minus 1 to the negative 1/2 really just means I have square root of x squared minus 1 sitting in the denominator, and I have an x, don't forget this guy, I still have an x in the numerator. Okay, I'm going to do a little bit more simplification. I'm going to get a common denominator with this 1. Can we agree that this fraction bar has x squared minus 1 or square root of x squared minus 1 in its denominator? This 1 does not. So I'm going to give that 1 a square root of x squared minus 1 in the top and a square root of x squared minus 1 in the bottom. So as to give me, let's say 5 over x minus square root of x squared minus 1, that guy hasn't changed, times square root of x squared minus 1 minus x, all divided by square root of x squared minus 1. I've just used that 1, or treated that 1. That 1 became square root of x squared minus 1 over square root of x squared minus 1, so it gives me this fraction. You can clean this up even more. Notice that I want to point this out with a different color even. We have square root of x squared minus 1 minus x, and I have x minus the square root of x squared minus 1 down here. These are almost identical. There's almost the same exact term, except they're flipped. And because of that, you can cross them off, but produce a negative 1. So that's a quick rule you should kind of memorize. A minus b over b minus a. Those are almost the same. They cancel and give you negative 1. So I have square root of x squared minus 1 minus x, and x minus the square root of x squared minus 1. Those are the same thing except one's been flipped, so they cancel and produce a negative. So it gives me a final answer of negative 5 over square root of x squared minus 1.